Welcome back. We're so glad you're here with us today because today we are talking about your digital survival.
Yeah, that's really what it comes down to.
It is.
Yeah.
Because for 2 decades, pretty much anyone with a website, a brand, or a product, you've been playing the exact same game. You're optimizing for the blue link.
Right.
You type a query, you get a list of 10 blue links, you click one, and then you land on a page. But that era is, well, it's functionally over.
Completely over.
So what happens to your brand when you never even get the chance to be that blue link? Like, what happens when a user asks ChatGPT or Perplexity or Google's AI mode a question, and the LLM just gives them the answer?
Directly in the chat.
Directly in the chat interface, instantly, no clicking required.
It fundamentally rewrites the architecture of online discovery. I mean, the entire traffic funnel that businesses have relied on.
The awareness, consideration, conversion funnel.
Exactly. That whole journey is being compressed into a single zero-click generated response. If you aren't the entity the AI chooses to cite, you simply do not exist in that user's buying journey.
Which is terrifying. And that is our mission today. We are breaking down exactly how you push your brand in LLMs.
Right.
How do you make sure that when someone asks ChatGPT for the best enterprise software or, the top running shoes or the most reliable logistics partner, your brand is the one generated in that response?
We have to figure out how to be the answer, not just a destination.
Exactly. And we're pulling from an incredibly dense stack of intelligence today to figure this out. We've got the Princeton University research on Generative Engine Optimization, or GEO.
Yep.
We've got the latest ARCIS preprints on LLM parsing behaviors, the new technical specs for the LLMs.txt protocol, enterprise architecture breakdowns from Adobe's LLM Optimizer.
Which is fascinating, by the way.
So fascinating. And a massive structural case study from Pinterest on how they rebuilt their entire visual search engine for the AI era.
The stakes here are just existential. I mean, we're looking at Gartner projecting a 50% drop in traditional organic search traffic by 2028.
50%. That's just wild.
It is. That isn't a gradual decline. That is half of the internet's navigational behavior vanishing, just absorbed entirely by AI agents that synthesize answers on the fly. We are moving rapidly away from traditional SEO toward GEO, or search-augmented generative engine optimization.
Okay. Let's unpack this, because a 50% drop means the core KPIs that marketing teams have tracked for 20 years are suddenly obsolete.
Overnight.
Right. We aren't optimizing to be a destination anymore. We have to optimize to be a cited source. But that requires a totally different technical framework, doesn't it?
It really does. With traditional SEO, you tweak your title tags, you build some backlinks, and you try to push your page up a linear ranking.
1 through 10.
Exactly. But GEO isn't linear. It's probabilistic.
Probabilistic. Meaning what, exactly, for the listener who's trying to wrap their head around this?
Meaning the success metric is no longer click-through rate. It is citation frequency and mention probability. You have to understand that an LLM does not think in terms of web pages.
It's not looking at your beautiful design.
Not at all. It doesn't look at a wonderfully designed homepage and rank it. It thinks in terms of entities, relationships, and vector proximity. The Princeton research isolates a concept here that completely changes how we need to view brand authority. They call it brand gravity.
Brand gravity. Okay, let's dive deep into brand gravity because this fundamentally shifts the burden of optimization off of your own website and onto the broader internet.
It does.
The paper uses this brilliant concept called the Patagonia effect to illustrate how vector proximity works in an LLM's latent space. Can you explain that?
Sure. So if you prompt a model like GPT-4 or Claude with a query about sustainable outdoor clothing, the model is overwhelmingly likely to generate the word Patagonia.
Right.
Now, it is crucial to recognize that the AI has no personal preference. It doesn't admire Patagonia's corporate ethos or like their jackets.
On a fit.
Right, it's just math. An LLM is a statistical prediction engine trained on petabytes of data. We're talking billions of Reddit threads, Wikipedia articles, digitized books, news reports.
The whole internet, basically.
Exactly. And in that massive corpus of training data, the semantic tokens for sustainable, ethical, outdoor, and Patagonia are mathematically inseparable. Their co-occurrence probability is astronomically high.
So brand gravity is essentially the sheer mathematical weight of your brand's reputation compressed into the AI's neural network.
Yes.
It's the inescapable pull your brand has on specific topical tokens. But here is the terrifying part for a lot of brands. You cannot fake that with on-page optimization.
No, you can't.
Like a company can't just stuff the word sustainable on their homepage 100 times and expect ChatGPT to suddenly believe them.
They absolutely cannot, because modern LLMs are effectively performing a continuous high-speed reputation audit. They don't just ingest what you claim about yourself.
They don't take your word for it.
Right. They are weighting off-page signals much more heavily. They look at Wikipedia for neutral entity verification. They ingest Trustpilot and G2 for aggregate reputation scores.
They're scraping Reddit too, right?
Oh, heavily. They scrape millions of subreddits to analyze raw, unfiltered customer sentiment.
Wait, if the AI is heavily weighting Reddit and Trustpilot to calculate brand gravity, isn't that incredibly dangerous? Because brands already manipulate those platforms with fake reviews and astroturfed forum posts.
Yeah, that happens a lot.
So aren't we just moving the spam problem from Google's algorithm directly into ChatGPT's training data?
It's a valid technical concern, absolutely. But LLMs are actually much better at detecting sentiment manipulation than traditional search crawlers.
Really? How so?
Well, traditional search looks for keywords and links. If a spammer buys 1,000 links on Reddit, Google might have a hard time parsing the context of those links. An LLM, however, understands semantic nuance.
So it reads the tone.
Exactly. It can detect the repetitive, unnatural phrasing of bot-generated reviews. More importantly, it cross-references claims using something called a semantic triple.
The subject-predicate-object relationship. This is the foundational building block of the knowledge graph.
Precisely. Let's say your company is brand X. Brand X is the subject. Provides is the predicate. AI-powered accounting is the object.
Okay, Brand X provides AI-powered accounting.
Right. And the goal of your entire digital footprint is to consistently fill that object slot across the web. If industry publications, financial blogs, and your own technical documentation all consistently complete that exact semantic triple, the LLM hardwires that neural pathway.
But if there is a contradiction, that neural pathway collapses. Let's play this out for a second. Suppose your PR team is spending millions pushing a narrative that your software is an enterprise-grade luxury solution.
Okay.
But the actual developers on Stack Overflow and Reddit are constantly posting that your API is a buggy, cheap alternative. To a human reading that, it's just a discrepancy between marketing and reality.
Right. A human just rolls their eyes.
Yeah. But to an AI building a knowledge graph.
To the AI, that contradiction introduces statistical noise. The semantic triple is broken. The model's confidence score in your entity just plummets.
It loses trust in you.
Exactly. Because when an AI generates a response, it optimizes for accuracy to avoid hallucinations. If the vector math shows that your brand is associated with both luxury enterprise and buggy cheap alternative, the model doesn't know which is true.
So what does it do?
Instead of guessing and risking a wrong answer, it just completely omits you from the output. It plays it safe and cites a competitor with a cleaner, more consistent semantic triple.
Wow. Which means brand consistency is no longer just a marketing exercise. It is a hard technical requirement for visibility in generative engines.
It's the only way to survive.
But we're also not just dealing with the static data these models were trained on 2 years ago. We have to talk about RAG, Retrieval Augmented Generation. Because if you were trying to push your brand in LLMs today, understanding the RAG architecture is totally non-negotiable.
A RAG is the bridge between the AI's historical training weights and the present moment. When a user asks Perplexity for the best CRM software, Perplexity doesn't just rely on its base training data from a year ago.
Right.
It fires off an autonomous agent to browse the live web, retrieve real-time data, and inject that fresh context into its prompt before generating the final answer.
And because of that real-time retrieval, freshness has become the ultimate trust signal. The ARC's fifth papers diving into LLM parsing behaviors show that generative engines heavily penalize dormant content.
They hate stale data.
They really do. If your competitor updated their technical documentation yesterday and your last update was in 2022, the RAG system inherently assumes your competitor's data is more accurate, regardless of your historical domain authority.
It's a latency play. If you want to force an LLM to cite you, you have to continuously feed the RAG system fresh, structurally sound semantic triples. You need a content cadence that proves to the crawling agents that your entity is actively maintained and currently relevant.
Here's where it gets really interesting. Because the way these AI systems actually visit your website to get that fresh data is completely alien to how a human uses the internet. We have to pivot and talk about the invisible world of agentic traffic.
Yes. This is one of the most critical revelations outlined in the Adobe LLM Optimizer documentation. The industry is facing a massive measurement crisis because we haven't separated human browsing behavior from bot extraction behavior.
Let's think about a human user for a second. They click a link, land on your beautifully designed homepage, watch the auto-playing hero video, maybe hover over the drop-down menu, and eventually navigate to a product page.
Right, they browse.
It's a multi-step exploratory journey, and that journey triggers your JavaScript analytics tags every single step of the way. You see them doing it.
But AI agents, the bots deployed by OpenAI, Anthropic, Google Gemini, they do not browse.
They don't care about the video.
They don't care about anything visual. They are autonomous extraction tools on a strict latency budget. They parachute deep into the architecture of your site. They drop straight into a specific FAQ node, a dense Help Center article, or a raw API documentation page.
Just bypassing the marketing fluff entirely.
Exactly. They locate the exact semantic triple needed to ground their prompt, extract the raw text, and sever the connection.
And the most terrifying part for a CMO looking at a dashboard is that this agentic traffic is completely invisible in standard analytics platforms.
Totally invisible.
You literally cannot see the bots that are shaping how the entire global AI ecosystem views your brand.
And that's because platforms like Google Analytics or Adobe Analytics historically rely on client-side JavaScript execution. When a human loads a page, the browser fires a JS tag that pings a server and says, hey, record a session.
Right.
But AI agents often strip out JavaScript entirely to save compute power and reduce latency. They request the raw HTML payload, parse it, and leave without ever firing the analytics tag.
So how do we actually track this? If we are flying blind on the client side, how do enterprise teams know which of their pages are actually feeding the LLMs?
You have to bypass the browser entirely and move to the server level. The Adobe documentation details how enterprise tools analyze CDM log data.
Content delivery networks?
Yes, networks like Cloudflare, Fastly, or Akamai that sit between your origin server and the open web. By analyzing the raw HTTP headers and user agent strings at the CDN edge.
Strings like OAI search bot or Perplexity bot.
Exactly. By looking for those specific bots at the edge, you can track the exact footprint of these agents.
And when you look at those CDN logs, the data is staggering. The pages that are actively shaping the LLM's opinion of your brand are rarely the pages your marketing team spends millions of dollars designing.
Never the campaign pages.
Right. The AI agents are ignoring the flashy landing pages, and they are just hammering the deep structural informational pages. The terms of service, the spec sheets, the change logs.
Which brings us to a harsh reality that brands just have to accept. The zero-click experience. We have to recalibrate how we value web assets.
What does that look like in practice?
Let's say a user asks ChatGPT, how does brand X handle data compliance? ChatGPT's ARG agent parachutes into your deep privacy policy page, extracts the compliance protocols, flies back to the user, and generates a comprehensive, perfectly formatted summary.
And the user is totally satisfied. They got exactly what they needed.
Right. And your website gets 0 clicks, zero recorded sessions, 0 page views in your traditional dashboard. But your brand just successfully owned the narrative in an LLM output.
That's a huge shift in perspective.
The value of your website is shifting from a mechanism that generates direct traffic sessions to a structured database that generates brand impressions and authority signals within AI interfaces.
You are optimizing for extraction, not engagement.
Beautifully said.
Yes. And that fundamental shift dictates exactly how we need to build and format our digital infrastructure moving forward. If we know the AI is parachuting into our site strictly looking for raw data, how do we format the landing zone so they extract exactly what we want them to extract?
Well, the consensus across all the technical literature is very clear here. The way we have been structuring web data for the last decade is actively hurting us in the AI era.
Let's talk about the syntax of the web then. Why is Markdown suddenly the most important language for SEO, replacing complex HTML, JSON, or XML?
It comes down to a concept called processing overhead and token efficiency. For years, we've relied on JSON or XML to structure complex data behind the scenes. Those formats are incredibly powerful for communicating between traditional relational databases.
Right, machine-to-machine stuff.
But they're heavy. They're full of nested tags, complex attributes, brackets, rigid syntax. When an LLM, which is a transformer-based language processor, ingests a massive XML file, it burns valuable compute power and context window tokens just parsing in structural syntax before it even understands the semantic meaning of the words.
It's like handing someone a novel where every single sentence is wrapped in a paragraph of complicated algebraic notation explaining how the sentence should be read.
That's a great way to put it.
It creates massive cognitive friction for the AI.
It does. Markdown, conversely, is the native tongue of large language models.
Hmm.
Most of these models were trained heavily on GitHub repositories and Markdown formatted documentation.
It speaks their language.
It is lightweight, plain text, and strictly hierarchical. A single hash symbol defines an H1. 2 hashes define an H2. A simple dash creates a bulleted list.
It strips away all the digital clutter. The implication here is massive for anyone listening. If you format your content natively in Markdown, or ensure your HTML can be perfectly and cleanly converted into Markdown by a scraper, you drastically reduce the processing load on the AI agent.
You make its job easy.
Exactly. When the AI has an easier time ingesting your content, your semantic triples are parsed more accurately, your vector embeddings are cleaner, and you are cited with a much higher probability.
But Markdown is only the presentation layer. It makes the text readable. We still have to address the underlying semantic structure. The RSUV papers point out that roughly 80 to 90% of the world's digital data is unstructured chaos.
Just massive blocks of text floating in div tags.
And LLMs despise unstructured chaos. When a crawling agent hits a massive wall of unstructured text, it has to use probabilistic guessing to determine what that text actually represents.
Right, it has to ask, is this paragraph a product description? Is it a customer review? Is it a joke?
Is it a hypothetical scenario?
Right. And every time the AI has to guess, you increase the risk of hallucination or omission. So how do we give the AI a definitive blueprint so it doesn't have to guess?
We use schema markup, specifically JSON LD structured data, but we have to use it much more aggressively than we did for traditional SEO.
Awesome.
Schema acts as a deterministic label for your text. You are explicitly telling the AI agent, do not guess what this text is. The specific block is an FAQ, or this block is an organization profile.
Let's give a concrete example of this because I want to move past the theory so you can actually apply this. Imagine you have a return policy on your e-commerce site.
Okay.
To a human, a paragraph of text explaining that returns are free within 30 days is perfectly fine. You read it, you understand it. But an AI has to parse the syntax, understand the timeline, determine if fees apply. Instead of making it read the paragraph, schema allows you to inject invisible digital tags directly into the code.
Right into the back end.
Yeah. You literally declare the type as return policy, you set the return fees property to free return, and you set the return policy category to merchant return, finite return window.
You are bypassing the language processing entirely and feeding the LLM raw, verified database values.
Which they love.
They do. The technical guides highlight FAQ page, organization, person, and web page schema as the critical defenses against AI hallucination. By wrapping your most important brand narratives in strict schema, you make your content highly extractable. And in a zero-click, RAG-driven ecosystem, extractability is the only metric that guarantees visibility.
Which brings us to the most radical new protocol we've seen in the research, something that literally did not exist a few years ago. The LMMs.txt file.
This is huge.
We all know robots.txt and XML sitemaps. Those are the maps we give to Googlebot to tell it what to crawl. But the sources are framing LLMs.txt as the definitive infrastructure standard for the 2026 generative web.
It is a brilliant, necessary evolution. The LMS.txt protocol is a standardized markdown file placed directly in the root directory of your website. Its entire purpose is to speak exclusively to autonomous AI agents and RAG crawlers.
Think of it as a VIP access pass, combined with a highly curated guided tour. You are explicitly telling the AI agents, hey, ignore our messy legacy pages from 2018. Ignore our promotional fluff. Here are the exact URLs in clean Markdown that contain our most accurate, brand-approved, factual data.
But it goes deeper than just providing links. A properly formatted LMS.txt file can actually inject system prompts and context directly into the AI's crawling mechanism.
Wait, really? You can prompt the AI from your own server?
Yes, you can provide a brief, definitive summary of your brand entity right at the top of the file. You can define mandatory versus optional endpoints. By directing the LLM specifically to your highest quality, most structured data, and explicitly steering it away from outdated content, you solve two massive problems.
Okay, first, you reduce crawl waste. The AI doesn't have to burn compute power wandering aimlessly through your pagination.
Exactly.
Second, you regain narrative control. But let me push back on this for a second. If I am a brand, and I know ChatGPT is reading my LMS.txt file, why wouldn't I just stuff it with the most aggressive marketing fluff possible?
It's tempting.
Right. Like, why would OpenAI or Anthropic actually trust a file that I control?
Mm.
Aren't we just creating a new SEO arms race where people spam their LMMs.txt?
It's a great question, but remember how a RAG works. The LLM doesn't blindly trust your lms.txt file in isolation. It cross-references the claims you make in that file against your broader brand gravity.
Ah, the Wikipedia entries, the Reddit
Yeah,
threads.
the broader internet consensus. If
Yeah.
your lms.txt file claims your software is the undisputed market leader, but your vector proximity in the latent space says you are a niche startup, the AI detects the discrepancy.
And calls your bluff.
It does. In fact, injecting aggressive marketing fluff into your LLMs.txt is the fastest way to get your domain penalized in generative rankings. The models are trained to extract factual, neutral, semantic triples. If you feed them adjectives instead of data, they will ignore the file entirely.
So the strategy is raw, unvarnished utility. We have Markdown, we have schema, we have LLMs.txt, but what about the actual human-readable words on the page? How do we format our content to ensure it gets sucked into the LLM's context window?
The research outlines highly actionable formatting heuristics. First, abandon clever, vague copywriting for your headers.
No more puns.
No more puns. An H2 that says the road ahead is semantically useless to an AI agent. You need to use question-based descriptive headings. What is the future of AI accounting software? This matches the natural language queries users are typing into ChatGPT.
You also need to heavily utilize structural formatting, comparison tables, bullet points, numbered lists. LLMs excel at synthesizing tabular data.
They really do.
If you have a page comparing your product to a competitor, don't write it as a narrative essay. Build a strict markdown table. The AI will extract that table wholesale and use it to answer comparison prompts. Furthermore, don't exile your FAQs to a single page at the bottom of your site footer. Weave granular FAQ blocks directly into your core product pages, immediately following the relevant technical sections.
But the most advanced optimization strategy relies on an algorithmic concept called information gain. And this is where most traditional SEO content fails completely in the generative era.
Let's define that.
Information gain is a mathematical measure of how much new, unique, or verifiable value your content adds to a specific topic compared to the existing consensus already stored in the LLM's weights.
This is brutal for companies that rely on churning out generic blog posts. Remember, the LLM has already read the consensus. It has ingested every Wikipedia article and every top-ranking blog post on the internet.
It already knows the basics.
Right. If your marketing team writes a 1,000-word article that just repeats the top 10 generic tips everyone else is saying, your information gain score is absolute zero. The LLM has zero mathematical incentive to cite you because you haven't given it any novel data to synthesize.
Exactly. You are just echoing into the latent space. To push your brand in an LLM, your content must possess high information gain. That means proprietary data points, original research, unique verifiable case studies, or a truly differentiated technical perspective.
You have to bring something new to the table.
LLMs are explicitly programmed to prioritize and cite sources that inject semantic novelty into their context windows. If you provide the unique data point that completes a complex query, you become the cited source.
Which brings us to a massive structural roadblock that we have to address.
Well,
We've talked about all these brilliant ways to serve clean, markdown-friendly data to the bots. But for Fortune 500 brands, for massive e-commerce sites, there is a giant elephant in the room.
JavaScript.
JavaScript.
This is arguably the most complex technical hurdle in modern GEO. For the last 10 to 15 years, the entire discipline of web development has migrated toward complex client-side JavaScript frameworks. We are talking about single-page applications built on React, Angular, Vue, or Next.js.
Which are great for people.
They make websites incredibly dynamic, fast, and visually stunning for human users.
But what happens when an AI bot, operating on a strict latency budget, hits a React-heavy single-page application?
In many cases, it sees a completely blank screen, a white page, nothing. While Googlebot has spent a decade building highly sophisticated rendering engines to execute JavaScript, many of the newer, faster AI agents scraping the web for LLMs, like the bots updating Perplexity's live index, simply do not have the time or compute budget to execute complex client-side JS.
They just bounce.
They send an HTTP request, they read the raw initial HTML response, and if the content isn't there because it's waiting for JavaScript to load it into the DOM, the bot assumes the page is empty and leaves.
To the AI, your multi-million-dollar interactive digital experience simply does not exist. Your semantic triples are trapped behind a wall of unexecuted code. So what is the fix? Because you cannot walk into the CTO's office and say, hey, ChatGPT can't read our React site. We need to delete the entire code base and rebuild our enterprise platform in plain HTML.
You'd be fired on the spot.
You'd be escorted out of the building. So what do?
This is where enterprise architecture has to evolve, and it's heavily detailed in the Adobe LLM Optimizer documentation. The solution is not rewriting the core application. The solution is edge-based optimization. It is a highly elegant infrastructure workaround deployed entirely at the CDN layer.
The content delivery network. The network of servers distributed globally that sit between your actual origin database and the end user. Cloudflare, Fastly, AWS CloudFront.
Precisely. You deploy intelligent edge workers, essentially serverless functions, at the CDN level. When an incoming HTTP request hits the edge server, the worker analyzes the user agent string.
It looks at who's asking for the page.
Right. If the request is coming from a human browsing on Chrome on an iPhone, the edge server passes the request through normally, delivering the beautiful JS-heavy React application.
But if the edge worker detects an AI agent, if it sees Google Other or OAI Search Bot or Claude Bot, it intercepts the request.
It stops it right there.
It instantly routes that bot to a pre-rendered, server-side generated version of that exact same page. The CDN takes all the content that is usually locked inside the JavaScript, hydrates the DOM on the server, and serves the bot a pure, structurally perfect, perfectly formatted HTML document.
It's essentially a bilingual receptionist operating at the speed of light. The human user gets the dynamic visual presentation they expect. The AI bot gets the raw, structured, schema-rich, markdown convertible data it requires to build its knowledge graph.
Nobody's experience is compromised.
Latency is minimized, and it requires zero destructive changes to your core engineering code base. It is the ultimate strategic advantage for enterprise GEO.
But wait, let me play devil's advocate here for a second. Isn't this just cloaking? Because in the early days of traditional SEO, if you showed Googlebot a text-heavy page, but showed a human a flash-heavy page, Google would hit you with a massive manual penalty and de-index your site for deception.
That's true, they would.
So why won't OpenAI or Google Gemini penalize us for edge-based rendering?
Because the intent and the payload are fundamentally different. Cloaking was a deceptive practice where you showed the search engine a page about cheap car insurance, but redirected the human user to a site selling pharmaceuticals.
It was a bait and switch.
Exactly. Edge-based rendering, dynamic rendering, or SSR provides the exact same semantic content, the exact same facts, and the exact same semantic triples to both the bot and the human. You are just altering the delivery mechanism to accommodate the bot's technical limitations. Google and the major LLM providers explicitly endorse this architecture for JavaScript-heavy sites because it saves them immense amounts of compute power.
Okay, so the technical infrastructure is handled. You are serving clean data at the edge. But how do you actually measure success? If the traffic is invisible in Google Analytics and the ultimate user experience is a zero-click answer on ChatGPT's interface, how does a CMO prove that this investment in GEO is actually working?
The KPIs require a total paradigm shift. We have to stop looking at bounce rates, time on page, and direct sessions. We need to measure our share of voice within the LLM's latent space.
What are the specific metrics?
The primary metrics are citation frequency, semantic coverage, and brand sentiment.
Let's break those down. Citation frequency is exactly what it sounds like, right? Out of 100 queries related to your industry, how many times is your specific domain hyperlinked as a source in the generated output?
Yes. And semantic coverage is broader. It asks, are you only being cited when a user explicitly types your brand name, or are you capturing non-branded category-level queries?
Like if you sell project management software, do you only appear for queries about your brand? Or do you care when a user asks, how do I optimize workflow for a remote engineering team?
Exactly. And crucially, brand sentiment. When the LLM actually mentions your entity, what is the context? Is it recommending you as the premium option? Is it criticizing your pricing? Or is it just neutrally listing you in a bulleted list of 10 competitors?
How do you even track that across all these different models?
The sources reference enterprise platforms like Brand24 or the analytics dashboard within the Adobe LLM Optimizer. These are built to track these specific metrics continuously across multiple models. They run thousands of automated prompts daily to calculate your brand share of voice in GPT-4 versus Claude 3 versus Gemini, mapping how your semantic presence changes over time.
But what if you are a mid-market brand? What if you don't have a six-figure enterprise budget for an automated LLM tracking platform yet? The research suggests a highly effective, scrappy DIY approach that any listener can execute today.
I love this part.
Open up an incognito window, load ChatGPT, Perplexity, and Gemini, and start prompting them exactly like your target customer would. Ask them, what are the pros and cons of my brand? Ask them, who are the top 3 competitors in this industry, and how do their features compare?
Take the generated outputs and literally copy-paste them into a spreadsheet. Log the citations. Analyze the sentiment. Find out exactly what the machine thinks your weaknesses are, because that output is a direct reflection of your current brand gravity.
It tells you exactly where you stand.
Do this baseline test every month. It is a raw manual process, but it immediately highlights where your semantic triples are broken. If ChatGPT says your customer service is terrible, you know exactly what off-page narrative you need to fix. You cannot optimize your information gain if you don't understand your baseline vector position.
So what does this all mean when we scale these concepts up to an unimaginable size? We've talked about text, we've talked about code, but I want to pivot to section 5 of our deep dives because this case study pushes the boundaries of everything we've discussed.
Oh, the Pinterest study.
We are talking about Pinterest.
The Pinterest case study is a profound masterclass in adapting a massive legacy platform for the generative search era, and it tackles a unique monumental challenge, which is visual content.
Right, because everything we have discussed so far, markdown formatting, JSON LD schema, LMAMS.txt, semantic triples, all of that relies exclusively on text.
LLMs need tech tokens.
But Pinterest is a platform composed of billions of images. A picture of a living room or recipe does not inherently contain text. So how on earth do you optimize a billion silent images for a text-hungry, text-generating LLM?
Well, the traditional approach to this problem is basic image captioning. You run the image through a vision language model, or VLM, to generate a literal description of the pixels. For example, if you have an image of a woman standing outside in a dress, the VLM generates the caption, a woman wearing a pink floral dress standing in a green garden.
Which is perfectly accurate from a computer vision standpoint. But from a search intent standpoint, it is completely useless.
Completely.
Nobody in the history of the internet goes to a search engine and types, I'm looking for an image of a woman wearing a pink floral dress standing in a green garden.
Exactly. Descriptive accuracy does not equate to search utility. And this is where Pinterest's engineering team pioneered a concept they refer to as reverse search design, or visual GEO. Instead of training their VLMs to describe what the image literally is, they fine-tuned the models to predict what a human user would actually search for in order to find that specific image.
This is a subtle but incredibly powerful paradigm shift. You aren't optimizing for the object, you are optimizing for the latent intent.
It changes the entire architecture of their metadata. Instead of generating the literal description of the pink dress, the fine-tuned VLM looks at the image and generates highly contextual, intent-driven queries, spring wedding guest attire ideas, or garden party outfit inspiration. The VLM captures the aspirational use case, not just the raw pixels.
But the Pinterest engineers didn't just let the AI guess wildly. They enforced a strict mathematical distribution framework for these generated queries based on analyzing billions of historical search logs.
We put guardrails on it.
They mandated that the generated metadata be split into a specific ratio, 30% descriptions, 30% style and detail, and 40% use case.
That 40% use case allocation is the absolute secret weapon for LLM visibility. It generates queries like capsule wardrobe must-haves for 2026. These are the high-intent, long-tail queries that drive massive action and engagement.
But historically, these queries are almost never included in standard alt text or literal image captions.
Never.
By forcing the VLM to autonomously generate use case queries, Pinterest essentially manufactured billions of high-intent text tokens for images that previously had no semantic footprint.
They translated visual inspiration into perfectly optimized semantic triples that an LLM can easily ingest. But here's where it gets really interesting.
As if that wasn't enough.
Right. They realized that simply reacting to search behavior is too slow for the generative era. By the time a new aesthetic trend shows up in your historical search logs, the LLMs have already established their knowledge graph, and you are behind the curve.
You're playing catch-up.
So Pinterest deployed a system of agentic trend mining.
This represents the absolute cutting edge of autonomous SEO. Tell us how these agents work.
Pinterest deployed fleets of AI agents to proactively scrape and mine external internet signals in real time. These agents monitor Google Trends, TikTok hashtags, emerging cultural signals. They operate entirely autonomously. When they detect a rising spike in a specific semantic cluster, they run an internal filter to verify if the trend is relevant to Pinterest's core categories, and they check the internal database to ensure Pinterest actually has enough high-quality visual content to support a landing page.
Okay, so let's say one of these autonomous agents spots a massive sudden spike across the web for matcha green minimalist aesthetic. The agent doesn't send an email to a human marketing manager asking them to build a campaign.
No, it doesn't wait for a human to curate a mood board. The latency would be way too high.
So what does it do?
The agent immediately accesses Pinterest's multimodal embedding architectures. The technical papers detail proprietary models called PinSlip and SearchSage. These are highly advanced vector models that map both text and images into the exact same mathematical space. The agent uses SearchSage to instantly pull the highest quality, most intent-aligned images matching the matcha green aesthetic vector.
And then it just builds the page.
It autonomously generates, formats, and publishes a topically coherent, schema-rich collection page. Just like that.
Let's break down why an autonomously generated collection page is the ultimate weapon for generative engine optimization. Think about how an LLM's R agent works. When a user asks ChatGPT about matcha green aesthetics, the R agent wants an authoritative, highly consolidated source.
It does not want to synthesize 100 different single-image URLs scattered across the web.
It wants a dense, structured, highly relevant hub.
Exactly. It wants maximum information gain with minimum processing overhead. A dynamically generated collection page aggregates hundreds of relevant images, ties them all together with intent-aligned VLM-generated text, wraps the whole thing in JSON-LD structured data, and serves it up perfectly. By the time human users actually start asking ChatGPT or Perplexity about this emerging trend, Pinterest has already built, published, and indexed the definitive, structurally perfect answer.
They front-run the AI.
They do.
The LM's RGA agent crawls the web, hits this immaculately structured collection page, synthesizes the data instantly, and cites Pinterest as the primary authoritative source in the user's chat interface. It is brilliant.
And the performance data proves that this architecture works at scale. The case study reveals that this end-to-end visual Geo system delivered a massive 20% increase in overall organic search traffic.
20% at Pinterest scale is unbelievable.
It is. But the truly staggering metric, the number that validates this entire technical shift, is the generative search performance. Content that was processed through this VLM annotation and autonomous collection system experienced a 9.2x boost in generative search traffic compared to their unoptimized baseline.
A 920% increase in visibility specifically within AI engines, that isn't a marginal improvement. That is total market capture.
It proves unequivocally that adapting your infrastructure to align with the mathematical intent of an LLM is not just a theoretical exercise. It is a highly measurable, massively scalable engineering discipline.
It demonstrates that the transition from SEO to GEO is complete. We are no longer optimizing the presentation layer for human clicks. We are optimizing the data layer for machine extraction and semantic synthesis.
That's the new reality.
Okay, we have covered an immense amount of ground today. Let's synthesize this journey. The era of the blue link is dying. Traditional SEO is giving way to GEO and SEGEO. The game is no longer about driving a click to your homepage. It is about forcing an LLM to cite your brand as the definitive answer.
Right.
To survive this transition, you have to build undeniable brand gravity across the entire web because off-page reputation dictates your vector proximity. You have to eliminate digital clutter and processing overhead by structuring your data natively in Markdown, wrapping it in exact schema, and deploying an LLMs.txt file to control the RGIL crawling agents.
You gotta guide the bots.
You must fortify your technical infrastructure against agentic traffic using CDN edge-based rendering to solve the JavaScript problem. And following the Pinterest model, you have to anticipate intent, translating your content into the exact semantic triples the AI requires before the human even asks the prompt.
It's a radical transformation of digital strategy.
Yeah.
You have to assume that every piece of content you publish will be read by a machine first and a human second, if a human ever visits the page at all.
Which brings us to a final lingering question, a provocative thought for you to mull over as you audit your own digital footprint this week. We are rapidly, unstoppably approaching a web where autonomous AI agents are the primary consumers of your website's bandwidth.
You really are.
They're the ones reading your LLMs.txt files. They're the ones parsing your raw markdown. They're entirely bypassing your beautiful multi-million-dollar JavaScript web design. They're summarizing your value to the end user in a closed chat interface. So here's the question. At what point do you stop designing your website for humans altogether?
Wow.
At what point does human UX become a secondary legacy concern, and you start designing your digital presence exclusively 100% for the machines that tell the humans what to buy?
It is a profound structural question. We are watching the birth of the machine-to-machine web. The primary audience for our data is no longer human consciousness. It is algorithmic synthesis.
Something to think about the next time you sit down to write a blog post or update a product page or look at your analytics dashboard. Stop looking at it through the eyes of a human customer. Look at it through the vector space of an LLM. Thank you so much for joining us on this deep dive. We hope it gives you the technical frameworks and the strategic clarity you need to push your brand and stay visible in the generative era. Keep optimizing, keep questing the architecture, and we will see you next time.